You use these models today, and you probably didn't even know it. Every Google search, powered by BERT. Every ChatGPT conversation, that's GPT. Every smart reply in your email, a large language model. But here's what's fascinating. These two giants take completely opposite approaches. BERT reads everything at once, like scanning an entire page in a single glance. GPT reads one word at a time, left to right, predicting what comes next. Two models. Two fundamentally different philosophies. Both absolutely revolutionary. And the scale is staggering. BERT has 340 million parameters. GPT-3 has 175 billion. GPT-4 is even larger. These are the biggest neural networks ever built by humanity. In this video, you'll learn how pre-training changed everything, how BERT understands language, how GPT generates it, and how to choose the right model for your task. Let's meet the giants, step by step. Before large language models, building an NLP system was painful. Want sentiment analysis? You needed 50,000 labeled reviews. Want machine translation? Millions of parallel sentence pairs. Want question answering? Thousands of handcrafted question answer examples. Every single task needed its own data, its own model, its own expensive training process. Then came the breakthrough idea, pre-training. Step 1. Take a massive neural network and train it on the entire internet. Billions of words from books, websites, Wikipedia, forums. No labels needed. The model just learns language itself, grammar, facts, common sense, even reasoning patterns. Step 2. Take that pre-trained model and fine-tune it on your specific task with just a small amount of labeled data. Think of it like education. Pre-training is like going through school. You learn to read, write, and think. Fine-tuning is like specializing, medical school, law school, engineering. You don't learn to read from scratch for every subject you study. This is called transfer learning, and it's the key insight. Knowledge transfers between tasks. One pre-trained model can be fine-tuned for sentiment analysis, question answering, named entity recognition, translation, summarization. The list goes on. One model. Endless applications. This changed everything. In 2018, Google released BERT and changed NLP overnight. BERT stands for bidirectional encoder representations from transformers. That name tells you everything about how it works. Bidirectional. That's the key. BERT reads text in both directions simultaneously. Here's why that matters. Take the sentence. The blank sat on the mat. A left-to-right model can only see the. Not very helpful for guessing what comes next. But BERT sees the entire sentence at once. The blank sat on the mat. And immediately knows the answer is probably cat. BERT reads like a human, seeing the full context, not just what came before. So how do you train a model to read bidirectionally? With a clever trick called masked language modeling. Take a sentence. The cat sat on the mat. Randomly hide 15% of the words. The mask sat on the mask. Then ask BERT to predict the hidden words. It's like a fill-in-the-blank test, but with 3.3 billion words of training data. BERT also learned to predict whether two sentences follow each other logically, called next sentence prediction. What does BERT excel at? Understanding. Google now uses BERT for 100% of English search queries. It powers question answering, sentiment analysis, and entity recognition. But here's the catch. BERT can't write. It can't generate new text. For that, we need a different approach. Enter GPT, the generative pre-trained transformer, from OpenAI, the model behind ChatGPT. While BERT uses the encoder, GPT uses only the decoder part of the transformer. And GPT takes the opposite approach to BERT. It reads strictly left to right, predicting the next token. Watch how it works. Start with the GPT predicts cat. Now it has the cat. It predicts Saturday. The cat sat. It predicts on. One token at a time. Each prediction building on everything that came before. This is why when you use ChatGPT, you see the text appearing one word at a time. That's not dramatic effect. That's literally how the model works. Now here's where it gets mind-blowing. The scaling journey. GPT, 1 in 2018. 117 million parameters. It could write simple sentences. GPT, 2 in 2019. 1.5 billion parameters. It could write coherent paragraphs. So good that OpenAI initially refused to release it, calling it too dangerous. GPT-3 in 2020, 175 billion parameters. It could write essays, code, poetry. It could do math. It could translate between languages it wasn't explicitly trained on. GPT-4 in 2023, estimated 1.7 trillion parameters. It can reason, analyze images, and pass professional exams. That's a 117 times growth in just 5 years. What does GPT excel at? Generation. Text writing, code generation, creative writing, conversation. GPT doesn't analyze, it creates. So which approach is better? Let's compare them head to head. Let's put BERT and GPT side by side. BERT reads bidirectionally. GPT reads left to right. BERT is an encoder. GPT is a decoder. BERT trains by filling in blanks. GPT trains by predicting the next word. BERT's superpower is understanding. GPT's superpower is generation. Now let's see them tackle the same sentence. I love this movie because the acting was brilliant. BERT reads the whole thing at once. It sees love and brilliant simultaneously and instantly classifies the sentiment as positive with 97% confidence. GPT reads it left to right and wants to continue. I love this movie because the acting was brilliant and the story kept me on the edge of my seat. Same text, completely different superpowers. So when should you use which? If you need to understand text, classification, search, question answering, choose the BERT family. If you need to generate text, writing, chatbots, code, choose the GPT family. If you need both, keep watching. Because here's the real insight. It's not BERT versus GPT. It's BERT and GPT. Understanding and generation are complementary skills, and one model tried to combine them both. Meet T5, the text-to-text transfer transformer. Google's attempt to unify everything. T5's brilliant idea. Treat every task as a text-to-text problem. Want translation? Input. Translate English to French, hello. Output, bonjour. Want sentiment? Input. Classify, I love this. Output, positive. Want a summary? Input, summarize. Followed by a long article. Output, a short summary. Want question answering? Input. Question, what is NLP? Context. Followed by a passage. Output, natural language processing. One format. One model. All tasks. And T5 uses both the encoder and decoder, the full transformer architecture. But T5 was just the beginning. The model zoo exploded. From BERT came Roberta. The same architecture but trained better. Albert, made more efficient. DistillBERT, made smaller and faster. From GPT came GPT-2, then GPT-3, GPT-4, and ChatGPT. From T5 came MT5 for multilingual tasks and FLAN, T5 for instruction following. And then others emerged, XLNet, Electra, Palm, Llama, Gemini. An explosion of models, each improving on the last. And the scale kept growing. BERT base had 110 million parameters. GPT-2 had 1.5 billion. GPT-3 jumped to 175 billion. Palm reached 540 billion. And GPT-4 is estimated at 1.7 trillion. From millions to trillions. Bigger isn't always better, but it often helps. These models didn't just improve NLP. They democratized it. Before, only Google and Facebook could do cutting-edge natural language processing. It required teams of researchers and millions of dollars. After, anyone can fine-tune a pre-trained model. A student with a laptop can now achieve results that took entire research teams. The numbers tell the story. Training GPT-3 from scratch costs roughly $4.6 million. Fine-tuning BERT for your task? About $10. So how do you choose the right model? Start with your task. Need understanding. Classification, search, question answering? Go with the BERT family. Need generation, writing, chat, code? Choose GPT. Need both, translation, summarization? Consider T5. Then consider your budget. Limited compute? Try DistillBERT or GPT-2. Moderate resources? BERT large or GPT 3.5. Unlimited? GPT-4 or Palm. Finally, how much data do you have? Lots of labeled data? Fine-tune. A little. Use few-shot learning with GPT. None at all. Try zero-shot prompting. Looking ahead, the trajectory is clear. 2018 brought BERT. 2020 brought GPT-3. 2023 brought GPT-4. Models are getting bigger, more capable, and increasingly multimodal. We're witnessing the most rapid advancement in AI history. BERT taught machines to understand. GPT taught machines to create. Together, they launched the large language model revolution. Next up, how to adapt these giants for your specific tasks, fine-tuning and transfer learning.